Hello lovely, in this video the brilliant Mr. B is going to be looking at tree diagrams for your A-level maths. Now there are lots and lots of examples in here and you're going to need to take careful note of the question to make sure we don't get mixed up. It is one of those slightly more topics that you have to pay attention to. If you want to check that you've paid attention to it enough and you're good with your revision, then over my website there are loads of practice and predictive papers waiting for you to download.
Have a look at tree diagrams, and for A-level they're going to work exactly the same way as at GCSE. You just might have some more complicated terminology. So for example, 6-sided dice is rolled and then a card is drawn from a deck. So we have independent events. These two events don't affect each other. We want the probability of rolling a 5 and drawing a spade. So we have the symbol in the middle, so it just means and. So this is what I'm talking about, and there might be more complicated terminology. So we start at the beginning of the tree diagram, and it shows all the possible things can happen. So we want to roll a 5, so we go down the 5 path. And then we want to draw a spade, so we go down the spade path. So out of the 4 possible things that can happen, this is the route we need to take. The other routes, for example, we have got not rolling a 5, and then drawing a spade. We have not rolling a 5 and then not getting the spade. And then the one just below the blue line is drawing a 5, which is what we want, but then not drawing a spade. So all these probabilities are kind of a yes or no. Either it's happening or it's not happening. So we don't have part of a tree, it's a dice of 6 sides. We don't have 6 branches, one for each bit of the dice. We just simply have what we want, the 5, or we don't have what we want, which is going to be the 1, 2, 3, or 4 or 6. We need to draw the probabilities onto this. Now the probability of drawing a 5 is 1 out of 6. So not getting a 5 is going to be 5 out of 6. So you can count up all things that are not a 5, like I just said. 1, 2, 3, 4, and 6. That's 5 things. Another thing you can do is these two numbers should add up to make a whole one. 1/6 plus 5/6 is 6/6, a whole one. Now the chance of not drawing a spade is 3/4. The chance of drawing a spade with this has to add up to a whole one, so it must be 1/4, because 1/4 plus 3/4 is going to make a whole. Then we have the part of the tree at the bottom that has no clues. However, these are independent events. What happens with a dice doesn't affect what happens with a pack of cards. Therefore, it's going to have the same probabilities. Now, there will be situations where these change, which we'll look at later on, but if they're independent, they don't affect each other. They are going to be the same probabilities. So we have 1/6 and 1/4 on the route we want to take, rolling a 5 and drawing a spade. So what do we do to these numbers? Well, when you have the and symbol, you need to multiply. So we're going to times 1/6 by 1/4, and that's going to give us 1 times 1 is 1, and 6 times 4 is 24. So we have a 1 out of 24 chance. Now, if you wanted to, you could find the other routes. So we could find a 5 and not getting a spade, which would be 1/6 times 3/4, which will give us 3 out of 24. We could do not drawing a 5 and then drawing a spade, which would be 5/6 times 1/4, which is 5 over 24. And we could have 5/6 times 3/4, which would give us 15 out of 24. Now, why am I showing you all of these? Because we already have our final answer. It was 1 out of 24. Well, it's because you can use this to check your answer. So what you could do is you could try and add all these up. 1 out of 24 plus 3 out of 24 plus 5 out of 24 plus 15 out of 24. And what you'll find is all these add up to 24 out of 24. They add up to a whole one. And so this is a method to check your answers. The last thing to think about is that when you add these up at the end, you say I can have 1 out of 24, or I can have 3 out of 24, or 5 out of 24 can happen, or 15 out of 24 can happen. So when you say the word or, you're going to be adding. It's when you're saying and that you multiply. For the next question, again, we have a dice roll and a card being drawn from a deck of cards. So we have 2 independent events that don't affect each other. We've got the probability of not rolling a 5. The little dash meaning not. So we take the route from the start down to not 5. And that's all we're being asked for, really. So there's a couple of ways to answer this. The first way is, well, if we have not 5, there are 2 outcomes from not 5, and we could work out both of those outcomes. Now, first, we need the probabilities on the tree. So 1/6 and 5/6 make a whole one, and 1/4 and 3/4 make a whole one. They're independent events, so the top tree is going to have the same result as the bottom tree. So we can multiply these together. We can have 5/6 times 1/4, and for the second root, we can have 5/6 times 3/4. So 5 times 1 is 5, 6 times 4 is 24, 5 times 3 is 15, and again 6 times 4 is 24. So we have 2 answers, and all we need to do now is add them together to get our final answer. And so our final answer is going to be 20 out of 24. We can even write the probability of not getting a 5. Now, there is another way of doing this, and what you could have done is just take the value of not 5, which was 5/6. So we can write it either way. Now, you might be thinking, well, both of these answers are different numbers, what's going on? But if you look at the 20 over 24, if you divide it by 4, 20 divided by 4 is 5, 24 divided by 4 is 6, which gives you 5/6. So it's actually the same value. Now, personally, I would probably suggest the 20 out of 24 answer because it just gives you all the possible outcomes. There are 24 possible outcomes. That's, rolling 1, 2, 3, 4, and 6. It's all the other things in the deck of cards. So it kind of gives you a kind of better idea of how many events there are. Whereas the 5/6 is simplified, so we've lost a little bit of the information. That's will be a theme going forwards where we're not necessarily going to be always simplifying the fractions because the unsimplified fraction gives us extra information, such as how many events there are and how many events we want. Sometimes you have to construct the tree yourself. So here we have a 6-sided dice is rolled and then a card is drawn from a deck. And we're given some clues. The probability of not rolling a 3 is 5/6. So let's add that to our diagram, and this will be our first event. So we're going to have rolling a 3. And not rolling a 3. Not rolling a 3 will be 5/6. So rolling a 3 is going to be 1/6 because we're going to add together to make 6/6. And then to make these look different, let's just highlight the 3s. They're labels, they're not numbers that we're going to be doing maths with. Now, the next thing that happens is we have the probability of getting an A. There's the probability of getting an A given that 3 has happened. So what that means is the third is going to go up here, assuming that we've got A here. So again, the line means given that 3's happened. If 3's happened, then the probability is 1 out of 13. Now, because rolling a dice and drawing from a deck of cards are independent events, it doesn't really matter the A's that happened and 3's happened. So given 3 isn't really relevant for this question. So it's also going to be 1 out of 13 for not getting 3 as well. But this kind of terminology might be useful for future questions. Now, if drawing an A is 1 out of 13, then not drawing an A must be 12 out of 13 because they've got to add up to 13 out of 13. So as you can see here, the first step is always going to be fill in the diagram. It doesn't really matter what we're looking for in the question. Make sure you get your diagram done. And you've got all the options you might need afterwards. So what is it that we need? Well, the probability of rolling a 3 and not drawing an ace. So we're going to go the route to 3. And then we're going to go the route to not getting an ace. Along that route, we had the 1/6 for 3, and we had the 12/13 for not getting an ace. Multiply those together, 1 times 12 is 12, and 6 times 13 is going to give us 78. So the probability of rolling a 3 and not drawing an ace is 12 out of 78. Now, like the last question, you might be tempted to simplify, but you don't need to do it because this tells us there are 12 different ways we can get this outcome that we want, and there are 78 possible outcomes that can happen if you roll a dice and draw from this deck of cards. So it's useful to have it in this form. The next question doesn't have a template for us to use at all, but again, we can see we've got 6-sided dice, then we're drawing a card from a deck, so we know we're going to have 2 elements to our tree. The first element of the tree is going to be rolling the dice. And if we have a look at the numbers for rolling a dice, the probability of not rolling a 3 is 5/6. So let's put in rolling a 3 and not rolling a 3. Make clear these are labels, we're not doing maths with these 3s. Then what we are doing maths with is not getting a 3 is 5/6. So that's the first thing we've been given. Then we've got to draw a card from a deck of cards. so we can continue our tree upwards. Now, if we look at what it says that given that 3's happened, this is the probability of not getting a heart, and it's 3/4. So we're going to have a heart. I'm not going to try and draw it, so I'm just going to write H. Then the probability, given that 3's happened, so we'll go to the 3 section, not getting a heart is going to be 3/4. So it's telling us specifically in this place is where the 3/4 goes. Now we've got these, we can write in the rest. So if it's 5/6 not get a 3, it must be 1/6 to get a 3, add up to 6/6. And then it's 3/4 to get a heart, or to not get a heart. To get a heart is going to be 1/4. The events are independent, so it's going to be the same probabilities on the other part of the tree. Next, we need to look at what we're actually being asked. So it's good practice to complete the tree to start off with. Sometimes you get marks for this as well. What we're being asked for, we're not rolling a 3, and then we are drawing a heart. So let's look at the numbers on that route. We've got 5/6, we've got 1/4, times them together. 5 times 1 is 5, and 6 times 4 is 24. So we have a 5 out of 24 chance of not rolling a 3 and then drawing a heart. The next question also doesn't have a template for us, but again, it's the same 2 events. So we know for 2 events, we're going to have the first part of our tree, and then we're going to have the second part of our tree. If you had 3 events, you'd have another row, so you might come off again. That's if there's 3 events in a row. And then if each one didn't give you 2 options, give you 3 options, then what you could do is you could have additional trees coming off. So always look out for things like this as well. We might have different patterns of trees, but for the majority of questions, you're going to see 2 by 2. But again, not always, so just be careful with that. So let's look at what the question's asking for. Well, the probability of rolling a 4 on the dice. So we're going to have 4 and not 4. The probability of getting a 4 is 1/6. So not getting a 4 might be 5/6. Another thing to look out for is they might not give you this, because if it says it's a fair dice, then you should know that any one on the sides will be 1 out of 6. So you won't necessarily get that information. Then we're drawing a card from a deck. Now, we're drawing, it says not drawing a club. So again, I'm not going to try and draw the picture, but I'll use C for club. So I'm going to get a club, or we're not going to get a club. Now, given that we've not got 4, the probability of not getting a club is 3/4. So again, it's pointing to specifically this location for 3/4, none of the other 3 options. That means that getting a club must be 1/4, so they add together to 4/4, and they're independent events, so the upper tree is going to have exactly the same numbers. Let's look at what we're asked for. We're being asked to not draw a club. So the 4 bit is completely irrelevant. So we could get 4, or we could not get 4. So let's explore both options. And then we want to not get a club. So for both those options, we're going to go to not club. So given that we've got 2 options, do 2 calculations. The top one is 1/6 times 3/4, which is going to give us 3 out of 24. And the bottom one is going to be 5/6 times 3/4, which will give us 15 out of 24. So we add these together, then the probability of drawing or not drawing a club is going to be 3 plus 15 is 18 out of 24. Another thing with this is, as usual, these are only asked for one thing. The probability of not getting a club on the actual tree diagram was 3/4. Now, is 18 out of 24 the same as 3/4? Well, if you divide by 6, 18 divided by 6 is 3. 24 divided by 6 is 4. So yes, they are exactly the same number. Now, for our next question, we've got a bag that's filled with yellow and red tokens. And we're given one clue, and it's this 2 out of 7. We have a 2 out of 7 chance of getting yellow. So what this means is we're going to have 2 yellows, and then we're not going to have 7 red, we're going to have 5 red overall, because then these have to add together to make the 7. So if it's a 2 out of 7 chance of getting yellow, and red's 5, red will be 5 out of 7. Now, what do we put on the second set of trees? Well, a token's being taken at random, and then it's being replaced. So you might think these are dependent events, because if you've got a bag full of yellow and red tokens, we take one out of the bag, then that's going to affect the probabilities of the second choice. Well, because we're putting a token back into the bag, that means that it's going to have the same probabilities on the second part of the tree. 2 out of 7 for yellow, and 5 out of 7 for red. But this is really important. The replacement is extremely important, and we'll see more of this on the hard questions. Then we've got some more complicated terminology than what we've seen before. We've got P, Y, and Y. That just means a probability of getting a Y, and then getting another Y. So we'll look at what's on the root there. We've got a 2 over 7, and another 2 over 7. Multiplying them together, because we want both of them, it's an and, so it's a multiply. 2 times 2 is 4, and 7 times 7 is 49. And again, you could work out the other 3 possibilities, and they should all add up to 49 out of 49. But we've got our final answer here. We can say the probability of yellow, and then another yellow, is 4 out of 49. Our next question is another bag full of tokens. We have green and red tokens. We've got one clue, which is our 1 out of 6. That's for green, so we have 1 green token, and the total is 6 tokens, 1 out of 6. So we must have 5 red tokens. We are replacing the token as well before our second pick, so it's going to be the same probabilities on the second pair of the tree. Now, what are we being asked for? I want the probability of not getting red. So how do we not get red? Well, if we get green, then we don't get red. Then for our second pick, we want to pick green again. So to not get red, we've not gone through any red points here, only gone through green. That is 1/6 times 1/6, which is 1 out of 36. So we can say that the probability of not getting red, remembering that dash means not, probability of not getting red is a 1 out of 36 chance. Now the next one's also a bag full of tokens, this time blue and red, and now our clue is written as a decimal. And everything we've done so far has been in fractions, but tree diagrams can also be written as decimals. So this clue means that blue is 0.96. Blue and red need to add together to give 1. So what can we add to this to get 1? We can make a decimal the same length, 1.00. So it might be a little bit clearer now. It's going to be 0.04 to make 1. So now we know what red is. So even though decimals, not fractions, they still have to add up to 1. Again, we are still replacing the tokens. So it's going to be the same probabilities on the second part of the tree, on the top and on the bottom. Now I filled out our tree, you see what we're looking for, what the probability of blue and a red. So you might think, well, we can go to blue and then we can go to red. And this is going to give us an answer. So it's going to be 0.96 multiplied by 0.04, which altogether will give us 0.0. Now let's keep everything to two decimal places, so it's going to be 0.04. I'm actually getting 0.0384 there though. Now there is an alternate answer, and it depends what you're looking for. Now let's say, well, this is the probability of getting a blue first and then getting a red second. So this will be our 0.04. Now, what if we wanted the probability of getting 1 blue and 1 red? And it doesn't matter which order they come in. So you could have an alternate answer. You could have, well, you could get a red and then a blue, and that would still be 1 of each. So we have 0.04 multiplied 0.96. Actually, the same numbers are the way around, so it'll still be 0.04 to 2 decimal places. Now, we can add these together to get our alternate answers. Now, we're adding them together. We don't want to round this early. So let's get our answer in more detail. So it was 384. So we're going to add those two together, and that'll get us a probability of getting 1 of each. And that's going to be 0.0768. So to 2 decimal places, and I think I might edit this and just say 1 of each. That's going to be 0.08 to 2 decimal places. So it ended up being the same answer as if we had the previous one together, 0.04 plus another 0.04, but just worth checking because, there could have been a rounding error there. So be really careful on what it's asking you. Is the order important? If the order is important, it's 0.04. If it's not, then there's 2 possible ways to get 1 of each, and it's 0.08. Let's have a look at another example. Now for this question, our clue is 0.87, and that's for an orange token. We know that orange and the other token, yellow, have to add up to a whole 1. So we need to add 0.13 to get a whole 1. So now we know yellow. The tokens are replaced, so we have the same probabilities on the second part of the diagram. Look at what the question's asking us for. It's a probability of getting yellow and then orange. So if it's specific with the order, that means yellow first and orange second. And so that's going to be 0.13 times 0.87. So we can type that into our calculator and we get 0.1131. So the probability of yellow and then orange to 2 decimal places, like the question's being asked, is 0.11. Again, this is one where the order matters. If the order doesn't matter, then we'd have another thing to add on to the answer. The next question has a clue. It's 0.05 for blue. So again, the two numbers need to add up to make a whole one. What do we have onto 0.05? It must be 0.95. You can also think of these as percentages. You've got a 5% chance of blue and a 95% chance of red. Just times decimals by 100 to get the percentages. And that's another way you might actually see these written. So we know that red is 0.95. What about the second tree? Well, again, the tokens are being replaced, so it's going to be the same numbers on the second part of the tree. Now, what are we looking for? Now, this time it says the probability of getting more than one blue, more than or equal to one blue. So how do we get more than or equal to one blue? Well, we could do blue and blue. That gives us 2 blues. That's more than or equal to one blue. We could have blue and then red. That gives us 1 blue. That's more than or equal to, it's equal to. We could also get a red and then a blue. That's 1 blue as well. What we can't do though is have red and red. That will give us 0 blue, and 0 is not more than or equal to 1. So here we have 3 separate options. So we write down all 3 options, and then we can work them out on our calculator. So 0.95 times 0.05 is going to give us 0.0475. The second one's the same, got the same numbers the other way around. And then the last one, 0.05 times another 0.05, is going to give us, now I get on a calculator, 2.5 times 10 to the negative 3. So let's transfer that into a decimal. So let's get the 2 and the 5, move the decimal back 3 places. So that's 1, 2, and 3 places. So what we want to do now is add all of these together, because all 3 of these will get us what we want. So we can have the top one, or the middle one, or the bottom one. So I'm saying, or we can add them together. So type them all into your calculator, and we can write as our final answer, the probability of blue being more than or equal to 1 is going to be 0.0975, which to 2 decimal places would be 0.10. So keep in mind, when you're looking at a tree diagram, it might be that more than one of the routes will get you what you want. And if you do, add the different possibilities together. Now, the third question starts off the same way. So we have 2 out of 5 tokens are orange. So if 2 out of 5 are orange, then there must be 3 yellow tokens to get us up to 5. So yellow is 3 out of 5. Then we look to see if they're replaced, and this time they are not replaced. This has some major implications for what happens next, because what we can't do here is we can't say that orange is going to be 2 out of 5 again, and yellow is going to be 3 out of 5 again. This isn't what's going to happen. So if you think about it, we've actually taken a token out of the bag, and we are not replacing it. So there's 2 things that can happen when we take tokens out of the bag. The first thing is we could get orange. 2 out of 5 are orange. So let's imagine we've taken an orange token out of the bag. What's left over? Well, we have 4 tokens left, and only one of them's orange, because one of the orange tokens has left the bag. Now, how many yellow are there? Well, there were 3 yellow at the start, and we've not taken a yellow out, so that's going to stay as 3. As we've taken one of the 5 tokens out, we've got 4 tokens left over. So the upper part of the tree is going to be 1 quarter and 3 quarters, and again, they add together to make 4 quarters. Now, the bottom tree is going to be different again, because we have 3 out of 5 chance of getting a yellow, and we've chosen yellow. If we choose a yellow token, the chance of yellow goes down by 1 for the numerator, and the denominator goes down by 1 as well, because we've taken that yellow token out of the bag. The total's gone down by 1, and yellow's gone down by 1. Now, for orange, we started out with 2 orange tokens, and there's 4 tokens altogether in the bag. We didn't take any orange out, so it's still at 2. And we'll see that 2 out of 4 plus 2 out of 4 gives us a whole one. So the hard questions are an example of an event that isn't independent. It's actually dependent on what happens before. The first event changes what happens with the second event. So we actually get completely different numbers for all 3 parts of the tree diagram. Now the rest of it works out the same. So I want to find the probability. We had orange then orange. So we go down the orange route, then down the orange route for a second time. So we're going to have 2/5 multiplied by 1/4. 2 times 1 is 2, and 5 times 4 is 20. So the probability of getting orange and then another orange is 2 out of 20. So the start works the same way and the end works the same way, but what's different is the middle part, we put the numbers onto the second part of the tree, the top and the bottom. So the next question, look at the clue. 1 out of 4 for orange. So there's 1 orange, there's 4 in total, so there must be 3 blue. So this works exactly the same way as always worked. Then you can say, well, if we choose an orange, then the orange goes down by 1 and the total goes down by 1. If we choose a blue, then the blue goes down by 1 and the total goes down by 1. And then remember that these second trees also have to add up to a whole 1. So for the top, it must be 3 out of 3 to add to 0 out of 3. And for the bottom, it must be 1 out of 3 to add to 2 out of 3 to get 3 out of 3. You can also think about those second bits as if you pick an orange, the blue is not going to change, so it'll be 3 for blue, 3 out of 3. Or if you choose blue, orange isn't going to change, you haven't chosen an orange, so it'll still be 1 out of 3. Once you've completed the diagram, look at what we've been asked for. What the probability of not getting orange? Well, there's only one way you can't get orange. You must get blue and then another blue. That's going to be 3 out of 4 multiplied by 2/3, which is going to be 6 over 12. So the probability of not getting orange is 6/12. Now, the next diagram, our clue is there's a 0 chance of getting green for the second pick. So we can work backwards. Well, if we chose green, then green goes up by 1, and the total goes up by 1 for the previous green choice. Then we can say each element of the tree has to add up to a whole 1, so you must have 2 out of 3 for purple, and 2 out of 2 for purple on the top tree. For the bottom part of the tree, we'll just work it out what we did before. We're choosing purple, so it's 2 out of 3. Purple's going to go down by 1, and the total goes down by 1. Then you fill in the tree, so it adds up to 2 out of 2. Once the tree's been filled in, look what we've been asked for. What the probability of getting green and then purple. So green first, purple second. That's going to be 1/3 times 2 halves, which altogether is going to be 2 out of 6. So we can say the probability of green first and then purple second is 2/6. Now this is the order matters. If the order doesn't matter, they'd also have to have a look at purple then green, which would be another 2/6, which should be 4/6 altogether. Our next question, the clue is 7/8 green on the second pick. So on the first pick, green must have been 1 higher, and the total must have been 1 higher. For the trees to make 9 out of 9 and 8 out of 8, then we're going to work at the bottom part of the tree. We're choosing yellow, so yellow goes down by 1, and the total goes down by 1. Then again, both parts of the tree need to make 8 out of 8. Now that's dealt with, we have a look at the question. What the probability of green then yellow? Green first, yellow second. So it's going to be 8/9 multiplied by 1/8. 8 times 1 is 8. 9 times 8 is 72. So the probability of green first and yellow second, the order mattering, will be 8 out of 72. For our last question, the clue is that 3 out of 6 are yellow on the second pick. Now this is after we've picked blue. That means that yellow isn't going to change. The total is going to change. So yellow would still be 3, but the total will be out of 7. Now for blue, on the bottom part of the tree, it'll be 3/6 because they've got to add up to 6/6. So you want 1 less blue, and so going backwards, be 1 more blue, and 1 more in total. So that'd be 4 out of 7. And we see the 3 and the 4 add up to 7 out of 7, so that's going to be right. For the top, we're picking yellow. Yellow goes down by 1. The total goes down by 1. Then the second part of the tree has to add up to 6 out of 6. That'd be 4 out of 6. So little bits of logic you can use, moving forwards and backwards. You move backwards, then you can increase what you've chosen and increase the total. You can keep what you haven't chosen the same and still increase the total by 1. If you're going forwards, the thing that you chose goes down by 1 for the numerator and the denominator. What the probability of B being more than or equal to 1. So we can have 2 blues is more than or equal to 1. 1 blue is more than or equal to 1, but 0 blues isn't. So these are the only 3 choices we can use. So we've got 4/7 times 3/6, We've got 4/7 times 3/6 again. And we've got 3/7 multiplied by 4/6. So these are all our possibilities. So 3 times 4 is 12. That's for all three of these. And then for the denominator, 7 times 6 is going to give us 42. So we add all of these together, then we're going to get the probability of blue being more than or equal to 1. 12 plus 12 plus 12 is 36. 36 out of 42 chance. So the last thing to think here is always be really careful with the wording of the question. Sometimes the order matters. You might get one answer. Sometimes it doesn't matter. You might get two answers. And sometimes you might have something like this where you can get up to 3 answers. And if you get multiple answers, add them together to get your final answer.